Hello, good morning, good afternoon, and good evening, and welcome to this PV Magazine webinar coming to you from this afternoon in Berlin, where the sun is shining and Germany is seeing about 25 gigawatt hours of peak solar production in these autumn days. So welcome, I'm Tristan Rayner, an editor here at PV Magazine and your moderator for today. And we have an informative session ahead tackling power control in the new energy landscape as we look at the European Union's Network Code on Requirements for Generators, or RFG, and what it all means for the industry in 2022 and ahead, along with hardware in terms of power control units as well. So on the topic, our initiative partner Phoenix Contact will present insights into the ongoing transition of the grid and grid stability, the need for power control, as well as regulatory and hardware certification requirements across different EU member states, practical implementation details, and plenty more. It's going to be pretty interesting and detailed. Practical details are coming as well, as I said, case studies and real example schematics and references from projects that Phoenix Contact has completed in the EU. And towards the end of our session, we'll dive into our usual round of questions and answers, so stay tuned for that after the presentations today. And now to our presenters today. First up, we have Birgit Beyer, Product and Solution Management at Phoenix Contact, who has 15 years of experience in solar cells and is now responsible for the Power Control Unit and Power Control Unit certification at Phoenix Contact, looking at the decentralized energy landscape today for us. Welcome, Birgit.
Hello. Thank you.
You're welcome. Great to have you. And we also have Dirk Erhards, Industry Manager of Renewable Energy at Phoenix Contact. He's been around renewable energy since 2007, more recently focusing on power plant control and energy management for decentralized renewable power generation units as well. And Dirk will be speaking about practical implementation and hardware today. So welcome, Dirk.
Hello, Tristan. Thank you.
All right. So everyone, before our expert presenters take the floor, just some housekeeping as usual. So please do feel free to send in your questions today. This is an interactive session with a planned Q&A stop at the end. So as we go along, write in your questions via the big marker control panel and we'll get to them. One question we always get that you don't have to ask is, will the slides be available afterwards? Yes, all registrants will be receiving an email from the system with a link to the recording and the slides, which you can share with your colleagues, friends, connections, maybe your mum if you really want, after our event today. And of course, for anything else, the PV Magazine webinar team is standing by to answer any questions you have about the software or any other administrative matter that comes up. And now, so Birgit, let's get underway with you with our webinar, kicking off the presentations. So I'll step back and you take it away.
Okay, thank you, Tristan, for your nice introduction and a very warm welcome from my side and to this webinar, Certified Feed-in Management for Decentralized Power Generation. And the first part is my part, and I will have a quick look at the energy landscape. Then we will have a look at the network code requirements for generators and some control functionalities. So here's the first slide. We are in the middle of the transition of the electrical grid. As we all know, we're in the middle of a transformation process from central power supplies to decentralized energy generation, and the reasons for this have arrived in society and industry. Cost degression for renewable energy sources and accelerated cost increase for fossil fuels, as we all know, because of the current situations. And we are facing a fast-growing number of small power generation plants. And that is what I really wanted to show on the right-hand side. For example, in Germany, we have here the number of PV systems which were installed over the past 12 years. And in 2022, we will reach 350,000 PV systems. And altogether, we have a number of 2.6 million PV systems. And they will all have to be controlled and have to stable feed into the grid. And next year, we even have to double our efforts to meet the government plans. So, but we really believe all technical solutions are available today. So the next slide, we have a picture of the future grid. So this will not be longer just top to down, but there are many more generators. We have here wind power, we have big solar plants, we have office buildings with PV systems, we have industrial buildings with PV systems, and households and apartment houses, and many demands, and of course biogas and storage and so on. And the PCU is really needed to balance the supply and the demand. So, and to regulate everything in Europe, we need some laws, we need some regulations. And therefore we have the NCRFG. And the European regulation is prepared by the NSOE and by ACER. NSOE is a European network of transmission system operators for electricity, and ACER, the European Union Agency for the Cooperation of Energy Regulators. And the rules and regulations were laid down in 2016. And for a law, this is not a very big age. And the NCRFG regulates cross-border electricity trading and capabilities for frequency support and the provision of reactive power. The focus is on the power plant controller, or the PCU as we call it, and on the behavior of every power plant. On the right-hand side, I wanted to show the different levels, the European level on the top, with all the authorities, in the middle, the member states, for example, Germany, with specific regulations for the transmission system operators and the distribution system operators. And then on the level of the power plant, we have the contract with the grid operators and the technical connection conditions of the grid operators. And in Europe, we do have many different country-specific guidelines. So the next slide. Now I want to have a look at the 4 generator classes in the NCRFG. So you can see on the left-hand side, it really depends on the size of the power plant. And with the growing size of the power plant from A to D, the requirements will grow as well. You can see it in the list here. From the type B, a PCU is required. But every member state can, of course, be stricter than the network code requirements for generators. For example, here Germany, there's a limit at 135 kilowatt peak, and in Belgium, it's 250 kilowatt peak. And my colleague told me that this will soon be lowered to 56 kilowatt peak. Okay, so everywhere from type B, there's a PCU required. But let's look at the next slide. Not everywhere the PCU has to be certified. And to be exact, only in 3 countries there is an obligation for certification. And those 3 countries are Germany since 2019, and certification has to be done according to the VDE ARN 4110-4120. And then there's Spain since last year, and it's all defined in the NTS. And there's a specialty for Spain because there's a difference for the mainland Spain and the islands, because the islands are not connected to the mainland grid, and therefore there are higher demands for stability. And then we have Poland since last year as well, and it's all defined in warunki I procedury and so on. And all other member states do not have an obligation for power plants controller certificate. And the power plant systems have to be certified individually. Of course, all power plants have to be certified individually, but in those countries, you have more work with certification and testing and model validation. And it would be a better way to solve this confusing requirements if we develop international standard for testing, model validation, simulation, and certification. And this standardization of the certification obligations is under discussion now and is being pursued by NSOE. And we believe in the coming years there will be more certificates or more need for certificates. So Now we have a look at the control functionalities. First, I want to have a look at a power generation plant. This is a very simple power generation plant with 2 PV fields, 2 inverters, the transformer, and the grid connection point. The inverters convert active power from DC to AC and can provide or absorb reactive power. And the power control unit, here in the bottom middle position, controls active and reactive power at the grid connection point. And here you can see all the interfaces. The most important one is the connection to the grid operator via telecontrol. And you can use many different ways to connect to the grid operator, for example, Ethernet via 104 protocol, Modbus TCP, or a serial interface, digital setpoint definition, or analog setpoint definition. Then the inverters in this case, they have an interface via Ethernet, Modbus TCP, and then last but not least, there is a measuring device, the energy meter, which is very important to give a feedback from the grid connection point and is measuring all the parameters. It is connected via Ethernet with a Modbus TCP protocol. And now we have a look at the control functionalities for this. When you think of feed-in management, first you think about the active power, of course. And there are 3 functions implemented. And on the right-hand side, you can see it's always for medium voltage in the VDE ARN 4110 and for high voltage in the 4120, and for the active power, it's both the same. So first, there are active power gradients, and you get set points from the grid operator for network security management and from third parties like energy off-takers or energy trader. And the gradients are very important to get a smooth transition from one value to the next. Second, you have a prioritization of external set points between grid operator and third parties. And then you have a characteristic curve, the active power as a function of the frequency. Now we will look at this. Here the active power control, and on the right-hand side, you can see the power as a function of the frequency characteristic curve. And what you have to look at is the very narrow range of the frequency between 49.8 Hertz and 50.2 Hertz. And this is a non-critical grid state. And if you get above this value, then really the active power has to be reduced. And if you get below 50 Hertz, then really the power has to be increased. But for renewable energies, you're always in the decreasing because there's normally no reserve. So on what else do you have? You have some fallback options in case of malfunctions, the last valid set point, for example, or a fixed set point, which can be parameterized. So, and now we have an example for the prioritization of different set values. On this graphic, you can see the blue line. These are the set points of the grid operator. And in this case, the grid operator lowers the value from 20 megawatts to 12 megawatts. And then the PCU is ramping down the actual value to 12 megawatts. And now the grid, the third party or energy off-taker also lowers down the value. And then the PCU will lower down the value to 6 megawatts, whichever value is the smallest, to protect the grid. So, and now we have another look at the reactive power control. In this, you have 6 functions for the reactive power control. And first, you have, of course, a direct set point specification with voltage limiting function. You have 2 characteristic curves for reactive power as a function of the voltage. And then we have the reactive power as a function of the active power. And then you have the cosinus phi, so the power factor. You can, under 5, you can switch between the individual reactive power processes. And last but not least, reactive power prioritizing driving style. So you can reduce the active power in favor of the reactive power. So there is another small example for this, or how it looks like in the VDE. You have 2 characteristic curves, one for medium voltage and one for high voltage. And really the difference is that the intersection is shifted slightly from 1 to 1.004. This is the difference, and it's the same again. If the voltage is too high, then the power has to be reduced in this. Okay, what else do you have? You have a hysteresis about the reference voltage and an adjustable reference voltage. So what more do we have? We have some additional functions. Of course, something standard, a controller bridging, and you have like a signal release reconnection from connection point with voltage criterions. And let's have a quick look at this as well. There we have a power plant again with a PV field. And here, after a protection and disconnection of the power plant has happened, the voltage is monitored by the energy meter at the grid connection point. And then the PCU sends a release signal to the PGU, the power generation unit, when the voltage exceeds the adjustable limits. And those limits are here about 95% on all 3 phases. Okay, how this functionality does work, and what I can say, since all functions of the PCU, of our PCU, can be flexibly parameterized, we are able to meet the certification requirement of different countries like Germany, Spain, and Poland. And now, this was my last slide, and thank you very much. And I think my colleague will take over.
Yep, thanks, Birgit. So just before we have Dirk sign on, I was going to ask you. So you've mentioned a couple of times now that these EU requirements, Germany, Spain, and Poland have gone for the enacting the certification laws. Which countries are looking at it, possibly to come online to do this as well?
So I think maybe Denmark, maybe Italy, and maybe Portugal. So yes.
Okay. And so are they're in different phases of looking at it,
yes,
I suppose?
Yes. But it's not fixed now yet.
Yeah, sure. And did the pandemic slow things down in this way? Were things trending in this direction? That was my understanding maybe a year ago when I was writing about it, but I'm not sure where we got to.
I'm not so sure. We always have the supply problems, of course, with all the components and things like that. But I haven't heard about that. Maybe yes, because it slowed down everything, really.
Yeah, sure. Okay, no problem. Thanks for jumping on the impromptu question. So, yeah, you're able. Well, you can take a back seat for now, Birgit, but come back for the question and answer session towards the end. And for anyone who's joined late, you've been hearing from Birgit Beyer, who's the product and solution management specialist at Phoenix Contact, taking us through RFG, as we saw, control functionalities, active power control, and getting into some of those technical details we all enjoy. And for anyone who's just joined us, don't forget we welcome your questions. So feel free to type them into us, and we'll get to them at the end of our session today. It's always fun to try and stump someone like Birgit, so feel free. Okay, so now we'll be joined by Dirk Erhartz, who's the industry manager for renewable energy at Phoenix contact, and he'll take us through practical details and references from real projects commissioned in Europe, benefits of the PCU certification, and more. So, Dirk, you're there? Okay, yes. Fantastic. Take it away, and I'll step back and join you at the end of after your presentation.
Very good. Thank you, Tristan. So, some examples of real projects. Last year, Phoenix did in Europe about 1.1 gigawatt of power control projects. Some of these projects are rather big sites, like the ones that you see here, which is a total of 208 megawatts that was implemented in Portugal over 6 sites. I am myself connected to the Belgium office, and in Belgium we have a lot more small sites. A lot of them are rooftop sites with local consumption. And a typical example of such a plant is what you see here. So on the left-hand side, you see the cabinet that we would provide. See if this marker works, but so this is the power control unit with the software integrated. What else you see is power supply, UPS, and communication devices. And so from here we communicate with the RTU of the DSO, and we communicate with the inverters and with the switchgear. Schematics of such a plant look always quite similar with small variants. So here we have a 440 kilowatt plant where we have again a cabinet with the PLC integrated. This project was executed beginning of last year, and you will see that there is quite some difference between how the DSOs communicate, and even in this particular case we see an evolution in how this DSO communicates, because initially he started with analog digital signals, and then later on he switched to Modbus over RTU. So we receive the control commands, we receive the statuses of the protection relay, we have energy meter at the grid connection point, and also pull here P&Q of the site in. And then from here we send the control signals out to the plant in the field, and we have in the field switchgear, a main switch and a backup switch, where we have to read the statuses but also send control signals if we are asked to do so. And then we have the inverters, which in this case we can connect to the inverters through a data manager supplied by the same manufacturer. This can be the case, it's not always the case. We can perfectly well communicate directly with the inverters on the right hand side. So this is the standard setup. If we look at next example, so this plant was built in 2 phases. So we have a first phase that was built about 10 years ago, 750 kVAs. This is rooftop with local consumption, and the client added a new part to it, and because of this the total capacity exceeded 1 MVA, which was at that time the limit for power control. And so just the addition of this 350 kilowatts caused the DSO to put their telecontrol cabinet on site. So here you see that with this DSO we communicate over protocol 104. We receive the control signals, we also receive statuses, and the Modbus connection is actually used to send back meter values from the 2 fields. Measurements come in and are sent back to the RTU of Flivius in this case. The control commands come into the PCU, and from there over fiber, because the distance between the main cabinet and the elements in the field, so the inverters, is quite large. So we have remote IOs with a fiber connectivity between those cabinets. And then from the remote IO, we will then convert the signals back to digital signals, or we will be able to receive the RS485 signal and convert that to Ethernet over fiber. Again, here we have, for the newest plant, we have a data logger provided by the inverter supplier. That can have some advantages. It works well. We can communicate with this device. It's not necessary, as I said. And on the older inverters, which are here LTI inverters, we communicate directly with these inverters. And so there is quite a lot of variability. This can be Ethernet, like in the first case, it can be analog outputs, it can be RS485. So these are the things that we have to customize case by case, and we have to adapt the hardware in our remote IOs or in the PCU to be able to communicate with all these different devices. An extra functionality that we added in this case is that since the old plant receives higher subsidies or higher feed-in tariff, when we receive a control signal from the DSO, we will first of all reduce the new part of the plant, because we have less financial losses by doing that, and only if that is not sufficient will we switch also to the old plant and reduce that further. Excuse me. Another example is a large ground mount site where we have 9 stations that are very similar. So you see a station on the top right with our cabinet, our control cabinet, and then connected to that the inverter, the combiner boxes. So the inverter, the combiner boxes, then transformer alarms and meteo sensors. This complete setup is repeated 9 times, and all the PLCs are linked in a fiber ring. Excuse me. So it's a managed ring. Excuse me, just need a glass of water.
Yeah, no problems, Dirk. Take your time. A glass of water. You're all good. Going well.
Yeah, I think it will come back. I was sick last week and it's still lingering a little bit. So in the main cabinet we have the PCU. We have a link with, in this case, the ALIA, which is our TSO RTU, and this connection is 61850. Now, this is maybe a good time to talk also about commissioning. If I go back one slide, commissioning this type of plant would probably take you a day, maybe 2 days. But if we look at this scale of plant, 40 megawatt, utility scale, TSO connected, then we have a lot of other elements that come into play, a lot more tests to be done. And it's really at this level where certification can help us a lot in the commissioning. Without certification, you probably are looking at 3, 4, 5 weeks of commissioning tests. While if you can prove that a lot of the tests have been done before and are certified, you could move ahead a lot faster. During this commissioning, a number of tests have to be gone through, and they have to be documented really in detail with detailed power analyzers or even with oscilloscopes. You have to apply rent rates, you have to maintain certain values, etc. So this is just active power. This one is a bit more interesting. So here you see the gray curve here, that is reactive power, and in this test we have to go from maximum negative to maximum positive as fast as possible. And you see when that is done, so this gray curve that flips from negative to positive, you see there is an impact on the voltage. The voltage goes up with about 1 kilovolt, and that is really the link between reactive power and voltage that Birgit also talked about when we talk about the characteristics. Another and last example is a plant where we have 2 different types of generators. So here we have 2 cogeneration units and we have PV. Again, we have the same DSO ORS, but here you see that the commands are sent by Modbus RS485. And we communicate with the cogen over just analog signals. With the inverters, we do it through Ethernet SunSpec. Some special requirements can always apply, like this client wanted to have a touchscreen display. He wanted to have a link with his SCADA system to have the main values in his SCADA system. That is functionality that we can add or that our integration partners can add. Good. So then a few other potential benefits of a PCU. Everyone is hopefully familiar with the power factor. So if you represent a typical consumer, let's say a factory that also has motors, drives, then you will have some reactive power consumption next to the active power consumption. And here are some numbers that are valid for Belgium. If your cosine phi or your power factor is above 0.95, you will get free reactive power. Between 85 and 95%, you have 15 euros as a fee per megawatt hours. And if your cosine phi is below 0.85, so if it's really bad, then you will pay a higher fee. This is without PV. Now, if we add PV to this side, what will happen is that the average operating point will move to the left because it's a generator. And if we don't control the inverters, it will be 100% active power. So it's a horizontal vector. So initially this customer will be quite happy because he gets less power from the grid, less active power, and the power from his own PV park should be lower in cost. So he's quite happy. But then after a while, he gets his bill and he sees that now his operating point is really on the graph above, but it means that the cosine phi is lower than 0.85. And so he takes the same amount of reactive power from the grid if there is no control, but he pays a higher price for it. That is something that I've seen many times. It creates conflicts. The good thing is if you add a power control unit, you can actually bring this point down and you can make the situation better than what it was before the PV was added. And then a last example, and Birgit already touched on it, that is that control commands can come from the DSO or the TSO, but they could also come from the energy off-taker. An energy off-taker for the TSO who's responsible for balancing the grid, is really a balance responsible party. So they have to maintain the balance between generation and consumption. If they sell a number of kilowatt hours, they have to make sure they also have them supplied. And they work on a whole series of markets, from forward market to the day ahead market to the intraday market. But then 5 minutes before the time of delivery, and this is the way it works in Belgium, but I think the rest of Europe has variants on this mechanism. 5 minutes before the moment of delivery, the TSO takes control and looks at what the real imbalance is. And at the moment of delivery, if you have a disequilibrium, if your supply is not equal to your demand in your perimeter, you will have to buy or sell energy on the imbalance market. And on the imbalance market, we see very big fluctuations in prices. We didn't see that 5 years ago, but today the fluctuation is bigger, and this is just 1 week in May of this year. Well, it's 6 days in May of this year, and every day the prices have some points of negativity, sometimes longer, but every day we have at least 1/4 hour of negative prices. And the price differences between the lowest price and the highest price in 1 day, this is just an example, it can be much bigger than this. Now, the owner of the PV facility doesn't face this price. He probably has a fixed price, but the company that buys his energy probably has balancing responsibility. And if it's not them, then it will be the party they sell it to. At the end, somebody needs to take this balancing responsibility. And that is exactly why energy traders sometimes don't like renewable or don't like solar energy. They say, yeah, well, we have no control, so it's not worth the same per kilowatt hours. Because if they have a position whereby they have an excess in their perimeter, they have too much energy in their perimeter, and they have to actually sell energy at this time, they will be paying with each kilowatt hour that they put on the grid, they pay this price of 500 euros per megawatt hour, because prices are negative. So if we can give them a tool, a power control unit that will actually cut the production when necessary. If they give us a signal, prices are negative, please stop injecting. That's very easy to implement on the power control unit. We just need to agree on the protocol. But the power control unit as we have it can be used to reduce the output certain moments of the day when needed, when there is an excess of energy. Good. I think that that was the last technical slide, and here you have our contact details.
Okay, no, thanks, Dirk. We've come to the end of your session. So that was Dirk Erhardt, the industry manager of renewable energy at Phoenix Contact. And that actually brings us to our Q&A session. So we've had a few questions already, but as I've been saying throughout, this is an interactive session. So feel free to type in some more. We'll do our best to get to them over this session. So Dirk and Birgit, yeah, we're on camera now. We'll bring Birgit back. Yes.
Yes.
And we'll tackle some of the questions being asked. But Dirk, if I may for a second, I just wanted to ask you the same question I sort of asked Birgit before. So Belgium's not on that list with Germany, Spain, and Poland, I guess, in defining those NC RFG rules. What are you hearing about that? Can you talk about why Belgium?
No, there is no talk in Belgium. What they've done in terms of standardization is standardized on communication protocols as much as possible, but not really on commissioning and processes or certifications. No, that is not being discussed yet.
Okay. And you were saying during your slides that commissioning without certification or without the certified hardware can take 3, 4, 5 weeks. How much faster are you if you are certified and everything's sort of in place?
Yeah, well, I've looked at one case where we had the option given: either you do the test and you make sure that it's documented, or you show us the certificate. And I think that applied to at least half of the test. So you could probably cut the time by 50% through certification.
Got you. Okay. And while we're just talking about certified hardware, Birgit sort of mentioned, I guess everyone's feeling a little bit of stress in terms of being actually able to get your hands on hardware in terms of inventory delays and supply chains and so on. If you just maybe this isn't your area for either of you, but in terms of what Phoenix Contact is able to do in terms of a customer says today, how much longer, what's the lead time you're looking at to get their hands on the gear?
Okay. This is really not my business, but
no, that's fine, and it's okay to say that as well.
But I think because Phoenix Contact is a well-established company, we have some connections, and sometimes this works better. That's what I heard from my colleagues.
Okay, no problem. Good to know. Okay, so some of the questions we had in advance are a little bit longer, so let's see how we go. And either of you feel free to jump in, or I can direct the question. But someone says they're interested to learn the approaches to studies and simulations to prove compliance with RFG. So Birgit, that might be one for you. So there's not exactly a question there.
No,
but I suppose they're saying, what are you doing in your labs in terms of studies and simulations, and how do you go about proving that compliance to get certified?
Well, we have a library, and in Germany it's Power Factory, and we have a library for the Power Factory, and then there are models for the Power Factory. And with this, we have a certificate, also a certification for our power control unit. So our certification institute did all the model validation. And so it only has to be once, and we don't have to do it ourselves. So this is a really good thing about certification.
Yeah, got you. When I was writing about this about a year ago, the feedback was even Phoenix Contact was slightly worried about certification being, difficult and expensive. But you only have doing it once, and then having that as a certified piece of hardware seems to be a real advantage as it's played out.
Yes, it is hard work and it needs money. Yes, and you have to get to know, especially the foreign rules. We are all from Germany, so Germany is we know better. But when it got to Spain or Poland, so this was a lot of hard work.
Yeah, I tried reading the Spanish royal decrees regarding this, and it's complicated. It's an interesting, you need some professionals.
So you need some strong partners and a good certification institute and so on.
Gotcha. Okay. Moving to the next question. Someone's asked about regulations in the Danish and Swedish markets. I guess these aren't necessarily the markets we're across. You mentioned Denmark may be considering RFG. Do you know anything about what's happening in Sweden?
No, I'm
That's
sorry.
fine. No problem. Not everything can be answered, so no problem at all. Next up, what technical means are necessary to dynamically settle electricity consumption and feed-in with changing prices for supply and demand? Or maybe also outside our scope a little bit, but Birgit?
I did really get the question, to be honest.
Yeah, no problem. I guess it's sort of saying...
Could you repeat it, Tristan?
I can, but I still don't know if we're going to get to the bottom of the question since it's worded a slightly oddly, but I'll read it again. So what technical means are necessary to dynamically settle electricity consumption and feed-in with changing prices for supply and demand?
Yes, it's really about an energy management system, what
Yeah.
needs to be set up. And we are working on it. And in Belgium, I think there has been a lot of work done in this direction as well.
Yeah, indeed. Well, I mean, we can control the inverters in a very detailed method. We can measure at the grid connection point. So if one of the things that could be the consequence of changing prices is the fact that you do not want to inject in the grid anymore. If you have negative prices in the imbalance market, as I explained, the off-taker may not want to inject that energy in the grid anymore, and that is something that can very easily be accomplished. Now, if the question is more related to, for instance, the day-ahead price, where you get every day a table with hourly rates for the next day, then you could take that into account. But then we're really going into the area of energy management, maybe temporarily store it in batteries, and when the price is higher on the market, then extract it from the battery, for instance. But I think it's going beyond the scope of the PCU as such.
Yeah, no problem. Thanks for chatting that through. Okay, this is sort of the reverse of what I thought we might be asked, so bear with me. But someone says, with the PCU, can one avoid the VDE 4110 certification process of the inverter in Germany?
The 4105, or what do you mean? So for low voltage, what is meant? Again, the question is not totally clear to me. And I can't hear you.
We lost you, Tristan.
Yes, we lost you.
Well, meanwhile, I would like to say that no, I don't think with a PC you still have to certify your inverter. I mean, it probably depends from country to country, but I know that there is the Synagrid list in Belgium, for instance, with certified inverters. And whether you use it with a PCU or not, that doesn't matter. If it's not on the list, you cannot use it. So I would be surprised that a PCU can replace certification of an inverter.
Yes, I agree. I totally agree.
No, we cannot hear you.
We can't hear you. And we can't see any questions, I'm afraid.
But I think he's coming back.
Oh, you still can't hear me?
Yeah,
oh.
Yes. We hear you now.
Okay.
Welcome back.
Thank you. Thanks for managing in the meantime. Sorry about that. Yes, I did hear you answer the question, so I think we can move on. But sorry about my technical difficulties. Okay, more questions coming through. So I guess this is for you, Dirk, but do you have application examples in France?
I think we have them. Yes, we do have them through an integration partner. Correct. Yeah.
Okay. So yeah, I guess there's no need to try and pull one up now. But is there something? Is there a way to get this to this person somehow?
Yes, that's possible. If you could provide me the details, then I can put them in touch with the right person.
Okay. Sure. Thank you. Appreciate it. Do all RFG use the same control in terms of Modbus protocols, or does the user get a choice?
In some cases, you have a choice between, for instance, analog and Modbus, but in other cases, it's there's just one particular protocol that is prescribed, and it does change from one DSO to the other and from one TSO to the other. There is not really a uniform solution.
So,
okay.
And you've seen that probably in the examples, right? That it was always something different.
so it's not specified in the NCRFG.
Okay. This one's a little bit specific, but the maximum length of the communication cable, I guess that depends on which protocol you're using.
Correct. Yeah. So if that's the traditional length that we face, that is Ethernet 100 meters, RS485 would be up to 1 kilometer. And then if you need Ethernet longer than 100 meters, then we use fiber, like you could see in that example.
Okay. Thank you. Okay, I'm just sifting through these questions. We've got quite a lot just coming in now, so that's great to see. Birgit, maybe for you, maybe Dirk, you can add something afterwards, but have you found differences between the countries that have integrated the European RFG in their regulations? And is there any particular differences or relevant ones that you could mention?
We had to do some changes, but not in our core, in the functionality core. And the one difference I mentioned in Spain, that there are differences between the mainland and the islands. And on the islands are not connected to the grid, and therefore the response time has to be much higher. But we could get with our function controls, we could get all the certificates for all the 3 countries, and just by parameterizing all the values.
Okay, thank you. We're just going to jump to a slide now. Someone's asked, so slide 11, I'll see if I can pull it up
slide
here.
11.
Okay. Okay, just 1 second. I have to get to it. I'm nearly there. Slide 9, slide 10, slide... Oh, no, wait. I know which one it is. It's actually this slide. So point 6 on this table, which mentions... Oops. Did we just
Which one
on?
is it? I'm sorry, I interfered.
This one.
No, problem. It's, I think, yeah, we can, yeah, there's a slight difference between what we see and what the audience sees as our slide numbers, but we got there. I know which one we're talking about. So point 6 here, which is about reactive power, prioritizing driving style. The question is the reduction of active power in favor of reactive power done by inverter itself or by the PCU?
So it's done by the inverter, I'm quite sure.
Okay.
Yep,
so because it's always the control is over the PCU, and then it's done by the inverter. Dirk, can you
Yes, I agree. I agree. It's done in the inverter, but we have to request that action from the inverter.
Okay, thank you. Now a question about the Netherlands. So what about new requirements for the Netherlands RTI, which I'm not aware of, but maybe you guys are. Is Phoenix contact ready?
RTI, I don't know, to be honest, if you don't have the whole...
We're going to hit Google just for a second, just so we can see.
We actually, we were in the process of certification for the Netherlands, but then we found out that there's no certification needed in the in the coming years. So we dropped it.
Okay, no problem. That sounds more complicated than what I'm able to help with right now. But obviously, Phoenix Contact is aware of what's happening in different countries as they move their regulations. Yes. Okay, another question. This one's a long one, so bear with me. Grid constraints such as very low or close to 0 short circuit current level in transformer side do not allow grid connection even with self-consumption scheme. How can PCU help?
Did you really understand this, Dirk?
I'm not sure if no. I think it would be worth to repeat it.
Yeah, and it's possible we can take this question offline as well, since it's quite technical about short circuit current level. But we'll definitely get that question across to you, and move on to what kind of setup in terms of communication hardware or software would be needed over the PCU for the integration of RTU?
Yeah, was that not explained on the schematics then? That
yeah,
was
I
really
think so.
The purpose of these schematics. I could go over them again, but
No, I think you did a pretty good job. Maybe this person joined late, so possibly they can review what your slides, which they'll receive at the after this event. So for that person, keep an eye on those schematics, and if you have any further questions, Dirk's contact details are there where we can reach out. Okay, okay, another couple of questions. These are getting a little bit more tricky, so
Okay.
Thanks for helping so far. But how is the DSO signal or commands handled when the energy management system, EMS, or the BRP also send signals? So is there a priority system in place?
Yeah, that's for you, Birgit. You explained that on the graph.
Which one? So you mean the priorities?
Correct.
Priority between third parties and grid operator?
Exactly.
Yes, of course. Always the minimum value for the active power has the highest priority.
Sure.
So it's always like that to really stabilize the grid and protect it.
Okay, no problem. Thank you. That actually makes a lot of sense. It's a good answer because
Yes.
I'm like, oh yeah, of course, that makes sense. That's natural. Okay, possibly another too technical one, but how can we implement grid monitoring and control signaling using there's an IEC standard here, using an IEC protocol with an ABB relay in between the grid and the Phoenix contact interface?
I can't answer to that.
That's a very detailed question,
Yes.
and we would have to see the details of that relay.
Sure.
And
that's a perfectly acceptable answer here, because we don't want to get if we get into the details, we might be here until 6 p.m. instead of 4 p.m. So no problem. One or two questions about negative imbalance prices. No, let's leave that one. And lastly, I think this might be the last question we handle here. How fast the generation unit has to react after a DSO command? So what's the reaction time required?
They can be different. I can't give you a number here.
Okay, but it's certainly in the millisecond range as far as I can.
Not all. Not always. I have one
really.
graphic, and it was, I think, 100 seconds or something on the one page. But it really depends. It really depends.
At the DSO level,
5 seconds. It was the one I had in my mind, and on the island again, it was 250 milliseconds. But this is really for island.
Yeah, so that would be DSO level. A DSO level is very often in minutes. DSO level can be that they want to see a first step response in 250 milliseconds. That's about the strictest that I've heard.
Yes.
Okay. I said that was the last question. I lied. There's one more, just good one, I think, which is your control system capable of having a redundant controller to satisfy hot or warm backup requirements?
Yes. We have already we have cases like that.
Perfect. Yes. Okay, I think you're off the hook. I think that's it for our questions. Thanks so much for answering. People, obviously, we have a few different languages. There's a lot of different member states in the EU here, so I think everyone does their best with questions, and we do our best with answering. But if there's anything more, of course, you're able to contact Dirk and Birgit, and
yes.
Get more help from them or the Phoenix Contact team. So I think that's a great place to leave this for today. So big thanks to all of you for joining, as I already said, and thanks to everyone who submitted a question, especially on this technical sort of topic. And thanks as well to our presenters. Thanks to my colleagues behind the scenes here at PV Magazine for some great help setting everything up, as always. So thanks, Diana and team. Otherwise, as you can see there, the October edition of PV Magazine is out now. And you can see there a busy edition talking about how to manage more solar coming online for grids, with Australia being one of the examples, where there's a focus on new solutions, including software solutions, and a bunch of other topics as well. So Central Asia's solar, world of solar, I suppose, is on the rise. There's a deep dive into microgrids. We have a couple of articles about how cobalt is being squeezed out in some battery types and how it's holding on and why. The same sort of thing about copper in solar cells. And one that I really enjoyed, which was a special report from China on the new players in the PV industry there, and their slight preference that's emerging towards HJT solar technology for their solar cells as the world moves from PERC to N-types. And not only that, we also have plenty of fresh solar and renewable industry news published on our website as well. You can see there our most read articles over the last little period has been new solar tiles from Germany. Everyone likes to get a new product on their rooftops. So Sandra's article there is interesting, and Ryan's written one there on pairing batteries with rooftop solar, which is a bit of a look at yeah, I guess the shift that we're seeing from everyone having rooftop solar to everyone having rooftop solar and battery, or at least trying to get their hands on batteries. So plenty of interesting stuff happening there. We also have more great webinars coming up as well. Coming up is on Wednesday next week, is how to diversify and grow lead generation without additional ad spend. And I had a look at that because I didn't understand the title, but that is Aurora Solar telling us about how to handle lead generation, how to grow it, and get more clients for selling solar, I suppose. And on Thursday, we also have tailoring mounting systems for the Asia Pacific, which is looking at rooftops. And I think that's going to be an interesting one for looking at different types of roofs across different regions in the very diverse Asia Pacific region. So tune into that if you're interested. And that's just about it, I believe. One last thing, a survey will pop up after this webinar, and we'd appreciate your thoughts and feedback on how it all went. We obviously do this for you, not us, so any insights will go far. But otherwise, thank you all for watching this webinar. Thank you again to our presenters, Dirk and Birgit. And thank you, yes. And for wherever you are in the world, I wish you a good day or good evening, and we look forward to seeing you again soon. Bye now.
Thank you. Bye.
Thank you. Bye-bye.
Bye-bye.